In our video, we will be introducing an array of pin fins. By using Ansys, a special software responsible for studying such fins, we will be showing in part 1 the geometry of our fins. First, we sketch a circle of a chosen diameter. Second, this circle is extruded before creating a pattern of fins to form our array. Distances between fins and the length of each fin are specified by the user as you are seeing in this video. Next, we defined our enclosure by selecting our enclosure shape and cushion size, that is later on given a name on each side for boundary and inlet conditions. Part 2 contains the meshing process. First, we generate a random mesh and then we start enhancing our mesh by altering some details in sizing, such as the relevant center and many others. Also, the growth rate is a very important factor when we consider enhancing our mesh. Growth rate is the factor that takes into account the increasing nature of elements as we move towards infinity. After we finish working on the mesh part, we check our statistics for elements, orthogonal quality, and skewness. Part 3 contains fluent. We specify first the number of processors needed to iterate our solution. After that, we started working on our solution setup to specify our fin materials and boundary conditions in the vicinity of our enclosure. Air velocity is required and all input and output boundaries must be stated in this part. In our case, the base temperature is at 400 Kelvin and our fin tips at 300 Kelvin, same as the ambient surroundings. Air entering the enclosure is at 1 meter per second. We also need to specify our surface monitors in order to check later on our temperature profiles and contours. In part 4, we will be showing our graph results. Plotting such graphs is extremely important to check the validity of our design. Our first plot shows the variation of static temperature in Kelvin with respect to position in meters. We were also asked to plot a graph showing the difference between our analytical and numerical temperature distribution. Finally, part 5 shows our extraordinary results that include temperature contours, velocity streamlines along our fins, and the variation of wall heat flux. Thank you for watching our video, and I hope that we were able to cover up all the main points.